Ladies and gentlemen, thanks for watching the video. In today's video, I will show you how to program the Intel FPGA design security key via system general programming. For the 14 nanometer and 28 nanometer process FPGA, like ARIA 10, ARIA 2 and Series 4, and ARIA 5 and Cyclone 5. Also the Series 5. Those FPGAs support the design security key functions. And for the 20 nanometer processors FPGA, like ARIA 10 and the Cyclone 10 GX series, beside the design security key, those devices also support the security configuration. The design security key is one-time programmable, and the key length is 256 bits. And System General is the only one supplier to support off-board programming. If you need to check any detailed information, you can click this link to find out more detailed information. In this slide, I will show you how to program the design security key and the necessary material for programming that include below materials. First one is that you need to install the 9600 and 9800 program. You can download the software link by the FTP link here. And you also need to prepare one SG9800 program and also the socket board adapter. And besides the socket board and the program material, you also need to prepare the SG data file list and the gen and RBF file that is necessary, and the key program file to program the design security key. And finally, you can create a task file, then convert the task file to job file for mass production. In this slide, you can see this is the program and the socket board. And when you get the socket board and the program, you can refer to the user menu to install the WinUSB drivers. So once everything is ready, then you can start to connect the program PUI with the program for device programming. Okay, so this slide shows you how to create a HTTP data file list. Actually, the HTTP data file list is a text file. And the purpose is that you just need to specify the gen and RBF file name and its location. So for this example, that's the gen file name is the key.jam file, and the RBF file is like this. So when you create a list file, you need to include the header, because the PUI will recognize the header in the list file to judge this is the SG data file list. Okay, so in this slide, that besides that the key and RBF file, and you also create a list file. So in this the three file, those files are the key program file when you need to program the RTL FPGA, and you can keep the list file and gem RBF file in the same folder. Please make sure the RBF file must be equipped. So in this slide that you can see how to create a task file. So firstly, that when you execute the T9600 program PUI, you can go to the task manager to create a task file. So when you create a task file, you need to specify the task file name and select the device part number and also the socket board. Then you can click the next. In the next procedure, that you need to configure the programming flow, like the brain check, program, verify, and secure. Okay, so in the third stage, that you have to specify the data file list path via this function. Then if you run the demo mode to create the task file, please disable the checksum compare function. Otherwise, when you initiate the task file, the PUI will show you the checksum compare error. because you do not get the really device checksum via the demo mode. Okay. In this slide, when your task file is created, you can go to the task manager and convert the task file to job file. Actually, the job file will combine the device driver and the data list file, task file, and also the gen and RBF file. So the job file actually has the password protected, so you cannot extract the data without a password. So you can see the below procedure. When you create a task file, then you can click the job icon. So when you click the job icon, the PUI will pop out the message. Do you want to pack the data file into the job file? Then at this moment, you can click yes. So once click yes, the PUI will start to pack the job file. So after several seconds, you can see the PUI will pop up. The job file is ready. Then you can click OK. So in the screenshot, you can see actually the job file will include those material, job driver file, RBF file, gem file, task file, and also the device driver. Okay, so once the task file or job file is created, you can connect to the program via the PUI. So after program is connected, you can download the task file or job file, and you can see the screenshot like that. When you download the list file, the PUI will download the gem and the RBL file. That depends on the file name or the page that you specify in the list file. So after that, you can get the device checksum here. So once the task file or job file is initialization, you can start to execute the program function, and of course that you can execute the standalone break check or verify once the device is programmed. And of course that you can also execute the standalone secure function to program the security bin. So in this slide, you can see that the 20 nanometer FPGA devices beside the design security key, they also support the security mode. So you can get the security mode description via the reference menu, and you can see there are a lot of security mode in the table. So you can choosing the corresponding security mode via the special bit edit interface. So once you confirm the security mode, you can click the confirm button to save the configuration. So in this slide, I will show you some error message and how to correct the error. For example, when you get the check ID fail, usually the check ID fail it stands for that the algorithm cannot read back the JTAG ID. So when you get the check ID fail message, it means that the program cannot read back the right device ID. So at this condition, you have to make sure the socket port is open absolutely. Then you can try to reinstall the device for programming. So if you open the if you can ensure that there's no any socket content issue, but you also get the check ID fail, maybe you can contact with the System General or Intel for fail analysis. And in this slide that I will show you, when you try to program the device but get the brain check fail, how do you do that? So the brain check function will check the design security key is a blank or not. So once you get the brain check fail, it means that the FPGA is not blank on the design security key area, and it might be programmed already. So at this condition, if you can ensure your device is a virgin chip and never be programmed, and the program should not report brain check fail. But if you still get the brain check fail issue, then you might need to contact with Intel to clarify the device is blank on the design security key area, or the device has been programmed already. So once you get the brain check fail, how can you reprogram the device? So in this condition, because in the general programming flow, the programmer will execute the brain check function firstly. So once your device is get the brain check failed, the PUI will reject the programming section. So at this condition, you can try to disable the check function. Then once you disable the check function, the programming flow will become the program and verify and skip the brain check function. So if the device is pre-programmed without the security configuration, and it means that when you try to disable the brain check function for reprogramming, you should be able to reprogram the device. Even the design security key is one-time programmable. And the condition is that you need to ensure the previous device has been programmed with the same design security key. Otherwise, we will get the program fail or verify fail. So in this slide that I will show you how the verify function work. So because the verify function leverage the PS mode to configure FPGA via the RBF file. So after the RBF file is configured by the FPGA, the algorithm will tapping the configure down and end a status pings, just like these two pings. So once the programmer can get the correctly configured down and end status ping, then we will report the program the verify function is pass or fail. So if you get a verify fail and you can ensure your RBF file is configured correctly, then it means that the design security key might not match with your RBF file. So if you always get verify fail, I think you need to ensure the RBF file configuration is correctly, and you also need to ensure the RBF file is matched with the design security key. And by the other hand, if the verify fail is occurs suddenly, and you can try to execute the reprogram function with brain check disable. The purpose is that you want to make sure if the verify fail device has been programmed the right design security key previously, and when you try to disable the brain check function, that you should be able to reprogram the device. Okay, so that is all of my SOP to introduce how to program the Artura design security key. If there is any question, please contact with the system channel for help. Thanks for your watching.